Next question, question 425. In this question, again, we need to determine the axial stress in the steel and concrete. Again, we have composite member. We have the combination of the steel bar and the concrete. For finding the axial stress, because we have the axial load, P is applied over this column, reinforced concrete column. For finding the axial stress, it is necessary just write sigma is equal to P over A. We have the cross-sectional area based on the dimensions that we have in the question. We need to find P for finding the stresses in the steel and concrete. Again, first equation based on the equation of equilibrium, sigma, if we write sigma Fy is equal to 0, we can write the total P is supported by P concrete plus P steel. This is equation number 1. Equation number 1. We know that P, based on the question data, the total P is equal to 1500 kilonewton. And equation number 2, based on the compatibility equation or concept, because steel and concrete are acting as a one member. That's why the deformation in the steel is equal to deformation of the concrete. That's why we can say delta concrete is equal to delta steel. You know that deformation of the linear elastic member under the axial load is equal to delta is equal to PL over AE. We can simply write here delta concrete, P concrete, L concrete, A concrete, E concrete is equal to P steel, L steel, and A steel, E steel. Because they have the same length, that's why this part and this part can be removed. And again, we can write P concrete is unknown. P concrete is unknown. Divided by how much is the A concrete? You know that? The area of concrete. This is a circular shape, and that's why it has a diameter 450 millimeter. And area of the steel. Area of steel, we have 6 bars. 1, 2, 3, 4, 5, 6. And diameter of each bar is 25 millimeter. That's why we can calculate here A steel. A steel is equal to 6 times pi d squared divided by 4. Yes. And area of the steel is equal to 2945 millimeter squared. For A concrete, we can say this circle minus the steel area. A concrete is equal to pi minus 2945 is equal to 156 millimeter squared. That's why A concrete, we can write here, A concrete is equal to 156 100. E concrete, based on the question data we have, concrete is 20 gigapascal. 20 gigapascal to megapascal is equal to P steel is unknown. A steel and E steel, 200 gigapascal to megapascal. After simplifying this equation, we can simply write P steel is equal to 0.1 0.8866 P concrete. We called it equation number 2 here. Equation number 2 based on the compatibility equation. Now we have one equation here, equation number 1, and we have another equation here. PSL is equal to 0.18866 P concrete. Two equations to unknown. If you put, for example, PSL is equal to this, inside the equation number 1 we have using equation 1 and 2, using equations 1 and 2, we can simply write P concrete is equal to kilonewton, P steel is equal to 238 kilonewton. After finding the P, we have the area. We can write sigma steel is equal to P steel divided by A steel. P steel kilonewton to newton, and A steel is equal to 2945. Sigma concrete is equal to P concrete, A concrete. We can say that 1262 kilonewton to newton, and this sigma steel is 80.8 MPa, and sigma concrete is equal to 8 MPa. Now again we review the question. The question was that determine the axial stress in steel and concrete. We have the composite member. It is made of steel and concrete. For finding the stresses in each material, we need to find, for example, we need to write famous equation, sigma is equal to P over A. And for finding the internal forces, the forces generated inside the concrete and steel, we need to write at the beginning equation of equilibrium, sigma of y is equal to 0. The total force 1500 is supported by concrete and steel. And next step, because we have composite material, for analyzing the composite materials, we need to add compatibility equations to equations of equilibrium. We can write delta concrete is equal to delta steel, because they are acting as a one member. Under the axial force, the deformation in the concrete and the deformation in the steel is the same. We know that the formation of the linear elastic member under the axial load, delta is equal to PL over AE. We can write P concrete, L concrete, A concrete, E concrete, PS steel, LS steel, AS steel, and ES steel. If you calculate the area of the steel, area of the concrete here, put here, and elastic modulus of concrete and steel here, we converted from gigapascal to megapascal, and finally we found this equation. Now we have two equations, equation number 1 and equation number 2 here. Using these two equations, we found that P concrete and P steel. After finding the internal forces, sigma steel is equal to P steel divided by A steel, P concrete, sigma concrete, P concrete, A concrete. Finally, sigma steel and sigma concrete. stress in steel and stress in concrete. Next question. Again, we have composite member. We have two different materials, aluminium and brass. Yes, brass and aluminium. Again, we can write the first equation based on the equation of equilibrium. Sigma Fy is equal to 0. We can say, for example, total P is 450 kilonewton. 450 is equal to P aluminium plus P brass. Equation number 1. This is equation number 1. Again, using the compatibility equation or concept, we can find equation number 2. Compatibility equation or concept. We can say that delta aluminium is equal to delta brass. Delta aluminium is equal to delta brass. You know that delta is equal to PL over AE. P aluminium, L aluminium, A aluminium, and E aluminium is equal to PBr, LBr, ABr, and EBr. This L and this L can be removed because they have the same length. And PAL is unknown. AAL, the area of the aluminium. We have two aluminium plates. We have two aluminium plates. Area of the aluminium, we can say that for the area of aluminium, AAL is equal to 2 times 60 times 10 is equal to 1200 millimeter squared. Yes, because here this dimension is 10 and times 62. We have two aluminium here, one aluminium and one aluminium here, and A brass is equal to 40 times 60 is equal to 2400 millimeter squared. That's why we have A aluminium. We have A aluminium. How much is it? 1200 times E aluminium. Based on the question data, we have 70. E aluminium is 70. We need to convert from gigapascal to megapascal. 70 PBr, ABr 2400 times EBr. EBr is 105 gigapascal to megapascal. Again, after simplifying this equation, we can find P brass is equal to 3 P aluminium. We called it equation number 2. We have one equation based on equation of equilibrium, and for finding equation of number 2, we used the compatibility equation or concept. Delta aluminium is equal to delta Br. Compatibility equation or concept is based on the deformation of the structures. Deformation of the aluminium is the same as the formation of the brass. That's why after finding the AAL and ABr, we can find PBr is equal to 3 times PAL. Now, the question is that Find the normal stress in the brass core and aluminum plate. Yes, next page. After finding these forces, simply we can find P aluminum because we have two equations, two unknowns. P aluminum is 112.5 kilonewton and P brass is equal to 337.5 kilonewton. P aluminum and P brass. Sigma aluminum is equal to 112.5 kilonewton to newton divided by area 1200, and sigma brass is equal to kilonewton to newton 2400. Finally, we can say sigma aluminum is equal to 93.75 MPa and sigma brass is equal to 140.6 MPa. Again, we review the answer. We have composite column. We have two different material, aluminum and brass. First equation based on the equation of equilibrium. Sigma Fy is equal to 0. P aluminum plus P brass is equal to 450. All the axial forces applied over the column is supported by the aluminum and brass. And second one, based on the equation, compatibility equation or concept, delta aluminum is equal to delta brass. After putting this formula inside the equation, we can find another relationship between the P brass and P aluminum. We have two equations, two unknowns here, P aluminum, P brass, and after finding the P, because we have A, for finding the sigma axial stress, sigma is equal to P divided by A. We can find sigma aluminum and sigma brass here. This is the answer.